When you hear the words bits and bytes, they sound abstract, maybe even boring. But here's the truth. Every single thing your computer does, from showing you a meme to running a video game, boils down to these tiny building blocks. If you can understand them, you unlock the way computers actually think. Let's start with the very smallest piece, the bit. A bit is just a 0 or a 1, nothing more. Think of it like a light switch. It's either on or off. Simple, right? But stack billions of these switches together and suddenly you have pictures, music, entire movies, even this video you're watching right now. Now, one bit on its own doesn't say much. That's why we group them into sets of 8. 8 bits make a byte. A byte is like a single word made out of letters. One byte can represent a letter, a number, or a small piece of information. For example, the letter A is stored as the byte 01000001. And that's the crazy part. Behind every text message you've ever sent, every emoji you've ever dropped, it's all just bytes dressed up in colorful forms. So why does the computer only use 0 and 1? It's because computers run on electricity, and electricity is either flowing or not, on or off. Using binary makes everything stable, predictable, and reliable. Imagine trying to build a Lego tower with only 2 types of bricks. It's restrictive, but also strong. That's why computers stick to this black and white language. Now here's where things get more interesting. Bytes are not just for letters. They also represent numbers, colors, and sounds. Take images. Every pixel in a photo is just a byte or more, telling the computer what color it should be. Music? Just streams of bytes that describe sound waves, videos, billions of frames, each made of pixels, compressed into bytes. So when you watch a TikTok video, what you're actually seeing is just a very elegant dance of bytes flying across your screen. To make sense of all this data, we use bigger units. A kilobyte is about a page of text. A megabyte is like a short book. A gigabyte, that's an entire library floor. And a terabyte. Imagine the library of a whole city. That's why your phone groans when it's full of photos and videos. Every picture is a few megabytes, every video is hundreds. They all eat into that limited library space. But here's the real twist. Storage isn't the same as memory. Think of your computer like a person working at a desk. The size of the desk is your RAM, your short-term memory. It's where you keep the things you're actively working on. The warehouse behind you, where you store everything long-term, is your hard drive or SSD. If your desk is tiny, you can only spread out a few papers at once before you're forced to constantly run back and forth to the warehouse. That's why computers with low RAM feel painfully slow, and there's another layer. Inside that desk, the computer has 2 ways of organizing its notes, the stack and the heap. The stack is neat and organized, like piling sticky notes on top of each other, quick but limited. The heap is like a filing cabinet where you can dump larger, messier things. It's flexible but slower. Programs juggle between these 2 spaces all the time, and if they mismanage them, that's when you get crashes, bugs, and lag. Think about the classic snake game. The snake's position is stored as variables in memory. Its body segments are stored in an array. The food? That's another variable. Each movement you make is really the computer updating those memory slots. If there's no space left or the game mismanages memory, the whole thing freezes. And that's the suspense. Every piece of software you use, from the tiniest mobile app to the biggest 3D game, is playing a constant balancing act with memory. Get it right, and everything feels smooth. Get it wrong, and the system crawls. So next time you run out of storage, or your laptop feels slow, remember, you're not just dealing with abstract numbers. You're watching the battle of bits and bytes and the delicate art of memory management happening right under the hood. If this helped you see computers in a new light, make sure to like this video, subscribe to the channel, and share it with a friend. In the next one, we'll go even deeper, looking at how different programming languages handle memory and why that's the secret behind their speed or flexibility.